Hello friends, and welcome to another video in our math series. This one is a challenge from me to you, and I'm calling it the Palindromic Number Challenge. What does that mean? Well, first we need to know what a palindrome is. So what is a palindrome? A palindrome is a word, sentence, or even longer construction that reads the same forwards or backwards. So, for example, here is a palindrome. The word dad, D-A-D, reads D-A-D in either direction. Mom is another example. M-O-M this way, M-O-M that way. Here's a slightly longer word, the word kayak. Again, you can see where I'm going here. K-A-Y-A-K, K-A-Y-A-K. No matter which way you read it, it says kayak. Now, you could have palindromes that are even longer. Here are a couple that are at the sentence level. Never, odd, or even. N-E-V-E-R-O-D-D-O-R-E-V-E-N. Read it backwards now. N-E-V-E-R-O-D-D-O-R-E-V-E-N. Again, it reads the same no matter which way you read it. Here's a really long one. Was it a car or a cat I saw? Was it a car or a cat I saw? Now, read it backwards. Was it a car or a cat I saw? Reads the same forward or backwards. Okay, so those are palindromes. Now, numbers can also be palindromes. Here are some examples. The number 121 reads the same this way as it does this way. The number 585, again, forward and backward, it's the same number. 1,441, 56,156, each of these reads the same both directions. A conjecture is a belief or a conclusion based on incomplete information. This is the conjecture that I'd like to challenge you with. I'm suggesting that any number can be simply transformed into a palindrome in just a couple of simple steps. Let me explain. Here's the number 523. It's not a palindrome, but if you use my steps, you can make it into one simply. Here's what you do. Flip the number backwards. So, 325. Now, I'm going to add the two together, and I get 848. By flipping the number and adding it to itself, I've made a palindrome in one step. Let's do one more. Here's the number 412. What are the steps? I flip the number backwards, 214. I add it to itself, and here I get 626. 626 is a palindrome, and I got there in only one step. Now, are they all that easy? Let's look at another one. Here's the number 684. I'm going to flip that number and write it beneath and add it to itself. Let's see what happens this time. 6 plus 4 is 10, carry that 1. 8 plus 8 is 16, plus 1 is 17, carry that 1. 6 plus 4 is 10, plus 1 is 11. Now, not a palindrome. However, I'm going to do my step one more time. And when I add these two together, I get 1, 8, 8, 1. This time, it is a palindrome, and I got there in two steps. Okay, let's try one more. Here's the number 798. How many steps will I need this time to make this number a palindrome? I'm going to flip it, and let's start adding them together. So 8 plus 7 is 15, carry that 1. 18 becomes 19. 8 plus 7 again is 15, and 16. Well, not a palindrome, so I'm going to flip that number, add it to itself, and let's see what happens this time. Here I get 6, 15, carry the 1. 15 again becomes 16, carry that 1, and now I get 7. 7,656. Still not a palindrome. That was 2 steps. Let's try it again. I reverse this number. 6, 5, 6, 7. Add it to itself. I think you can make a prediction here. Will this resolve into a palindrome this time? Let's see. 6 plus 7 is 13. Carry that 1. 6 plus 5 is 11. Plus 1 is 12. 11 again, plus 1 is 12. 13 plus 1 is 14. Still not a palindrome. Let's keep going. Flip and add. 3, 2, 2, 4, 1. Add these 2 together, and let's see what happens this time. My final answer, 46,464. This time, I am at a palindrome. How many steps did it take me to get to a number that was the same in both directions? There was step 1, 2, 3, and 4. It took me 4 steps to get there, but I did end up with a palindrome. So, here's the conjecture again. Every number can eventually end up in a palindrome by using this step. Okay, here's the deal. We know that every 3-digit number has been found. They've all been solved, except for one. There is one 3-digit number out there that has not been solved. By that I mean that we do not know if it will eventually resolve into a palindromic number. I'm going to give you a clue. It's somewhere between 150 and 199. So here's my challenge to you. Can you find the one number in that series that does not become a palindrome by using those simple steps that I showed you above? Secondly, what numbers can you find that need the most steps to become palindromes? Most will be 1 or 2 steps. There are a few out there that might go beyond 4. There is one that you could do forever, as far as we know so far, without finding a palindrome. Can you find it?